Okay, so the paper I'm going to present today is called Built Interpretable Interaction Trees for Deep NLP Models. This paper is published at AAAI 2021. This paper has 9 authors, but I didn't find much information about the first 8. I guess they are all probably
under the 全10章, right?
He's
not
our
sure.
Machine learning teacher.
Oh, I guess they are undergraduate students because
yeah, I think
not
this
much
professor,
information.
I think this professor is very good at advertising his works, and I find a lot of the article in Zhihu by this professor. So
Really?
once I go through the paper list in AAAI last year, so I find this title and this topic is quite interesting, and also somehow related to Prof. Dong's favorite syllabus, has a little bit similar. This is some have there's a relevance here. So let's go through these papers, and also it's very relevant to the explainable AI part.
Yeah, I found that this professor has published a lot of works about explainable AI and
but his work is more towards attribution problem. His explainable AI is more towards attribution problem.
So the background is pretty simple. We know that deep models has achieved state-of-the-art in many research areas, and specifically in this paper, they are looking at natural language processing problems. So currently, many methods use some latent tree structure to make the DNN to learn interpretable feature representation. However, their limitation is that they might need to modify the DNN itself before training, and this could bring lower performance and make the whole training process to be inefficient. So in this paper, they wanted to explain the trained black box model in a post hoc manner so that you don't bring down the performance. And how did they do that is that they wanted to reflect the interaction between words embedding as explanations. The challenge of assigning an interaction score is that it's difficult to guarantee the objectiveness of the explanation.
Okay.
So basically, their contribution is that they propose a method to extract and quantify interaction among words that ensure the objectiveness, and then they propose a tree structure to represent the interaction encoded inside a deep neural network.
Sorry for interruption. So for their works, they are using the traditional DNN, or they can also extend to the CNN or their CNN transformer, etc.
I think it's model agnostic. They didn't mention much about the model structure itself.
Okay. So they don't care about the structure, the approach.
I think so, but they are working on NLP problem. But later we can see more about this. But I think they didn't mention why they use a tree structure instead of other structures. And the last contribution is that they designed 6 metrics to analyze those interactions.
So basically, tree structure is the most explainable structures up until now, right? Because you can think about this decision tree, especially the model is want to make a decision. It's trying to make a decision. So each node in the tree is supposed to be a decision to make, right? For example, we want to apply. For example, if we are undergraduate students want to choose which university to apply to further our graduate study, right? So if I want to be a professor, so this is a decision in the future. So I'm going to choose to be PhD. And if I want to be a rich professor, so I'm going to choose AI, right? So if I want to be a professor who does not care about money, so I will choose model checking, whatever it is. So each node on a tree supposed to be a decision here. So that's why the tree structure. But that is my intuitive understanding.
But in this paper, the tree is built up by a bottom-up manner, and I'm not sure. Later we can discuss about this.
Sure.
So we can start with some preliminaries by introducing Sharpie value. So Sharpie value is originally from game theory that tries to assign contribution to each player in the game with consideration of fairness. The setting is that we consider n players in the game, and we wanted to know how much is each player contribute to the final game score. A very intuitive way is that suppose here we wanted to know the contribution of player A for the game score. We can compute the game score on where you only have n-1 player participate in the game, and also you can calculate the game score where all n players plays, and then do a subtraction between the two scores. But here, for the formula itself, actually what we did is we iterate all the subset of the n-1 player, and you compute the difference between two scenarios. One is that the subset plus A, and the reward of subset S plus A, and the other scenario is the reward of subset S itself, and then you do the subtraction between them and compute the contribution of player A. So that's the high-level idea. I have prepared two simple questions here. So the first question is, how many possible choice of subset S in the power set of n-1? So if you have if you have n-1 player, and how many possible subset? So any volunteers?
Yeah, any volunteers? I'm gonna have a try. If I want to have a try. You find?
How many possible S in the power set of a subset A?
So you have n-1 player.
So the subset will be n minus how many? So how to say it? Let me think.
You can draw it. You can draw it.
Okay.
Basically, it is combination. It is a mathematical combination.
Yeah. So let me. So it is n-1 plus.
I mean, do you know what power set means?
Yeah. So for example, we have a set, right? It's A, B, C, D. Okay. So A is a subset, right? B is a subset, right?
An empty set is a
empty set. Okay. So does the empty set matter here?
Yes.
It doesn't matter. So whatever. So this is also a set. And how many subsets are there in this suppose this
so
is
here
S, right? Suppose this is S. And so what is
you have 4 players?
Yeah.
So I just computed all the subsets
Okay.
This is
Okay, I
for
get
the
you.
subset of only one. This is only for a subset with 2 elements.
Mm.
Yeah, so you just up the. Is it right?
No.
Okay.
No.
Let me check how many possible S in the power set of. So the power set is a subset or not subset? Is this a
No, so here empty set is a subset of S, and a set with only A inside is a subset. So how many subset if you have, let's say, 4 players?
how many subset? So not
the number of subset.
the number of
So if you have 2 players, then the number of subset is 4.
4, yeah. So it's
And if you have 3 players, it's 8. Right?
okay.
So can you conclude?
Can I have a guess?
That's it.
Yeah, I think that's correct.
Okay.
So for each player, actually you can think of it like each player you can either choose or not choose. So it's 2, and if you have n-1 players, it's 2 to the power of n-1.
I think this is high school math, right?
Exactly. Yeah.
Okay, and yeah, the second question is that when the subset size is m, then how many choices do you have for S?
So this is still a high school math, right?
Yeah.
You can
Yes.
pick up one.
So Meng Yue, can you have a try?
Hello, Meng Yue.
Yeah, I'm here.
So let's say we have, oh, sorry. So let's say if we have n players and you wanted to choose a subset with a size of m, then how many possible subset can you choose?
How many players do we have?
Yeah, so maybe I raise examples. Do A, B, C, D. Let S to be. Suppose we want to choose a subset S prime, whose size is 2.
2.
Yeah, and how many choices or how many ways to select such S prime?
Oh,
It's a combination. Maybe you can just
yeah,
say,
it's a
no need to calculate the exact number. You can just
C 4 2.
Yes. So yeah, that's correct.
Yeah. Okay, it's good for us to recap the math, the high school math. Okay. Then Xianglin is supposed to make a point.
Yeah, so here you can see a normalized term here with the red box. So the value is actually 1 over C and S. So I guess this normalized term tries to average out the number of subset S.
So that means to remove, I think it is going to remove repetitive. Right, there is a okay, so it may not be a remove, it's just to normalize, calculate.
Yeah, just to normalize.
Just to calculate the average. Okay. Okay,
Yeah.
so I think this is a very good explanation and a well-designed questions for us to understand the Sharpie value.
Okay.
Any questions here?
Hello. Can I ask why it is not n-1 choose S, but n choose S?
Yeah. I'm not sure. I think their paper is not that accurate.
Okay.
Yeah, because that's my understanding as well. Here, the n should be n-1, right? But
Yeah, you're right. But anyway, we get the picture.
Okay. And there are 4 properties of Sharpie value to ensure fairness. The first one is called linear property. That means if you have 2 different games, V and W, and if you merge the 2 games into one and wanted to know the contribution of player A to V plus W, then the contribution of player A to this merge game is equal to the contribution of A for game V and plus the contribution of A to the game.
By the way, so how can we interpret the plus between the game?
No, the plus just means you merge them into one game.
Suppose we play chess, right?
Oh.
So we play the chess, and how do we? Let me reason again. For example, we write a paper. Write a paper is a game, and whether the paper can get accepted is the score, right? And for example, suppose there are the students who contribute quite a lot. So without him or her, and the paper cannot be accepted. So and how to involve? What do you mean by writing one paper plus writing another paper? The score.
I'm not sure about this. So,
okay, so yeah, I'm still trying to come up with example. But anyway, so there is some. This is still we still are in the area of game theory, right?
And the second property is called dummy property. So let's say for any subset S, and the contribution of player A plus contribution of S is equal to the contribution of S and A, then that means player A has no interaction to any alliance to other player. So the contribution of A itself is equal to the reward of player A play alone minus the reward of no one play.
Well, by the way, sorry, I missed a point. So V is a game, right?
Oh, V is the reward or game score.
Oh, then what is phi?
Phi is the Sharpie value, the contribution.
Okay, I got it. So if the reward it has some linear.
So if the reward by S player, the score by.
But the Sharpie value is still a reward. Sharpie value means the difference of reward.
Here it tries to state the idea that A has no interaction with other player. Otherwise, the score of they playing together would be different.
Will be not linear.
Maybe positive, maybe larger or less.
This is still a linear property, right? So I'm saying that suppose.
But this is in the same game, but in the first property they are looking at 2 games.
Yeah.
So this V is different from the first V.
Oh yeah. So in the first V is one. It represents one game, and in the second property, the V means the reward you get after playing this game.
Okay.
And the third property is called symmetric property. That means if for all the subset S and S when S playing with A is equal to S playing with B, then the contribution made by player A and player B is the same. And the last property is called efficiency property. So if you sum over all player, the contribution of all player, then it should be equal to the reward you get if all players plays together minus no one plays in again.
Really? So that means that all the players play along. Once two players have interaction.
Because
suppose,
when you calculate the contribution of player A, you have already considered the interaction between them.
okay.
Right? Because you
and also
here you have considered the interaction.
So let me make a conclusion. So the Shapley value of a player it actually depends on his cooperator, right? So
himself and his cooperator.
Yeah. So basically, so despite their parameter, we have a parameter of A per se, but actually the Shapley value will change depends on his cooperator.
That's
and
my
again, and that's again because different players sometimes 1 + 1 = 2, but larger than 2 or smaller than 2.
Yes.
So the interaction in this paper is actually cooperation.
Yes, right? Yes. So that's why they want because in the previous slides we mentioned that they wanted to guarantee the objectiveness of explanation, and that's why they adopt the method from Sharpie value. So then let's look at how they calculate the interaction between two players or word embedding. So in this paper, they considered each word embedding as one player. So they define this B, which stands for interaction benefits. And B as AB, they wanted to get a score of the interaction benefits between player A and player B. And how did they do this? Is first they view A and B as a singleton player. And the first term is the Sharpie value of SAB. And then they minus the single contribution of A and B. So what's left is the interaction between player A and player B.
Yeah, so intuitively saying that we let so we first have the contribution of if A and B cooperate together. Then we try to remove the Shapley value of A per se plus the Shapley value of B per se. So we can see that if A and B work together, whether the cooperation can have some positive influence, right? So if the B is greater than 0, it means that if A and B cooperate together, we have the effect of 1 + 1 is larger than 2, right?
Yeah, that's the idea. And then they also extend this idea to multiple players. So if you wanted to know the interaction between a S, so S could contain multiple player. So first they calculate the Sharpie value of set S. So they view S as one single player, and then they minus all the single contribution of each player inside S.
You have no questions here. Any questions? Any questions for this slide? I think up until now, Xianglin is very, very articulate and explain all the concepts quite well. Okay.
And then they further decompose interaction benefit of set S into the second formula. That is, the benefit interaction of set S is equal to the benefit interaction between S1 plus benefit of S2 plus the benefit interaction between the two sets S1 and S2. So S1 plus S2 is S.
Okay. So it still have the
Mm.
linearity or no? Yes, no linearity. Okay.
And then they bring this concept of elementary interaction. To understand this elementary interaction, we can look at the example I provided here. So suppose we only have 3 players, A and B and C. And the elementary interaction of S or A and B and C is the benefit. Is the interaction benefit of S minus the interaction benefits of A and B, B and C, and A and C. Can you get the idea? Because the interaction benefit of
I got it.
S.
So IS is a more marginal benefits. Only evaluate the influence or the evaluate influence of benefits only when A, B, C work together. Right.
So that's why it is called elementary interaction.
Why is it called elementary? I think it's more like a margin. If I think the margin.
Anyway, so this formula actually just mean this. So first they calculate the benefit of all and then minus the subset S prime of S.
Okay, so maybe
Okay, and we have
also appropriate. Maybe also appropriate because it's only looking to the anyway the basic.
No, they just define this concept of elementary interaction here. And so I have a very simple question here. So suppose we have A, B, C, D 4 players, and does elementary interaction of A, B, C, D include the benefit of A and C?
Okay, so it's more like it's more towards more topics for the concepts. Yeah.
Probably Dr. Xiaoyan, Dr. Xiao.
Yeah, I think it includes.
No, I mean the elementary interaction.
Yes, it's elementary, not the
not the
not the B, it's I.
interaction benefits.
Elementary. Yeah. Yeah, because I have a question in the I'm waiting for
previous slides or
no. Here. Because I is from 1 to 6.
Oh, actually 4, 5, 6 they only have one single player, but anyway.
So I is from 4 to 6.
I is
from 1 to 6.
Oh, 1 to 6. Sorry about that.
Yeah, supposed to be 1 to 6. Here supposed to be 1.
So the idea is that the benefit of set S includes the interaction between A and B, B and C, A and C, and A, B, C. Yeah. And for the elementary interaction, they want to decompose the interaction benefit of S into
elementary.
yeah, so
elementary subset. Yeah. So you can think about it. You can write the equation back. So BS is equal to I sigma
IS plus
or I, right? So suppose all the subset S prime is supposed to S and it's supposed to be S prime. We can write here. You can write down this one, right? Xianglin, right?
Yes, yeah, you are correct.
Yeah. So in this case, each IS prime will be independent. That is my understanding. Despite A, B, C, D is a superset of AC.
So the benefit of ABCD definitely includes the benefit of A and C, but the elementary interaction between ABCD does not.
Independent.
Yeah. So that's the idea.
So can I say it? So the elementary means that if it is minus, that means only A, B, C left. I mean A and B and C.
Only yes.
Okay. Thank you.
So
Yeah, that's an interesting question. But I think the Sharpie value is very important for inferential analysis for our future deep learning research.
And then the next step, they claim that the elementary interaction can be computed via dynamic programming.
Okay, so maybe I raise a question to you.
Okay.
Okay. So
okay.
So for algorithm, so if we have the dynamic programming, so in this case, let me think about it. I would like to ask how much computation effort can it save if we turn the normal algorithm into the algorithm. But I find I still need some time to calculate because there's I think that suppose the complexity is supposed to n prime, n squared, right? So otherwise it's supposed to be log so exponential algorithm, something like this. And if we do this, we can build a matrix, and each line is supposed to be ABC,
and you follow a bottom up.
Yeah. So basically, we can calculate the values with such a matrix. Okay. Yeah. So that is so I think up until now, Xianglin's slides all all consists of very basic computer science, including evidence, combination, etc. Okay. So let's look forward to the novelty of this approach.
That's the old no.
That's already the novelty. Right?
Yeah, that's already the novelty of this web. And then they also decompose the interaction benefits between two sets into 3 parts. The first part is when you select players from both set S1 and S2 and get their elementary interaction. And the second part is the difference of internal interactions among players in S1 with respect to the absence and presence of player in S2.
Okay.
And the third part is the opposite.
So it's more for me. It's more like extend the concept to the set.
Yes. But with elementary interaction, they can decompose those benefits.
Okay. So that's why they want to use the concept of elementary.
Yeah, that's correct. I guess that's for easier computation. And here I need to mention their tree structure in the advance in order to understand the later metrics. So they built up the tree structure like this. On the bottom, each word, so each circle represents a word embedding, and and they construct this tree from a bottom-up strategy. At each layer, they merge 2 sets into one.
So I got all the points. But my question is, the tree structure just used for explanation, and how did this explanation? So for example, it only have a merged nodes, right? So the song, and the song has been merged into the song, and is going to identify the syntax of a or grammar of a sentence, or
No, they merge the two nodes because their interaction score is high.
okay.
So
So what
each
if what
at
if
each
what
level,
if what if there's a gap between the and some? They'll still try to merge the
the gap.
sentence.
What do you mean the gap?
Suppose we have in the sentence, I say the sun rises from the sea,
Oh,
maybe above the sea, whatever. So
oh.
if we find that the sun and the sea actually
Oh.
have a, and how do we merge them?
So in this case, in this paper, they only consider adjacent nodes. They would only merge adjacent node, and later they also have experiment to prove that if two nodes are far away, then their interaction score actually is insignificant. Anyway, another metric is called density of modeled interaction for player A and player B. So suppose you, I'm not sure, I think it's quite clear. So if you choose A and B and you wanted to merge them into singleton player C, and then the density is calculated by the benefit between A and B over BAB plus BA prime A. So A prime and B prime is the nearby or adjacent node to A and B. So if the value is large, then that means A and B interact with each other, while A prime and A and B prime and B has less interaction.
I got it. And based on the idea, I understand you can calculate the Sharpie value, calculate the elementary benefits and all benefits. So what? And maybe I jumped these questions too early, but based on these values, so what? What can we do based on this observation?
So they can, in the experiment part, they have one section to show how you can explain a model based on this.
Okay, let's go through that.
And then the SAB is defined as unmodeled interaction benefits. Density of unmodeled interaction of player A and player B. So,
okay.
And then later they extend this idea of density to set. So here A and B is leaf node, and here A and B is non-leaf node.
Once we have a singleton set, we definitely need to use it. So that is also straightforward. A practical question here is that since the Sharpie value is very hard to calculate, and how do you make sure it's efficient?
Yeah, that we will talk about it later. And then, how did they build this tree structure is at each layer they will find the max. Remember the density. So here they use this density of modeled interaction for player A and player B. So they find the max value and then merge AI and AI plus 1. And then in the next level.
But how the density value is calculated from B, right?
From benefits, you mean?
Yeah, from benefits.
And benefits is calculated by estimate Sharpie value.
And how do they calculate the estimate Sharpie?
So that's the first question we want to answer.
Okay.
So in the
so how do you calculate the estimate Sharpie value?
By sampling.
Okay, by sampling. But how much do we need to sample?
So that's the first research question. Okay. So in summary, in the experiment part, we have 5 questions to answer. First is how good is the estimate Sharpie value? And then the second question is, so from the previous slides, we have the assumption that interaction between non-adjacent nodes is insignificant. And here they wanted to verify if this assumption is correct or not. And then the third question is that is the extracted interaction correct or not? And then the fourth question is how can this method be used for explaining a model? And in the fifth part, they wanted to know whether this tree generated by their method and I think I spelled this wrong, but
syntactic tree.
Yeah. So how different are those two trees?
I think this paper has been rejected once, and the last question is a restart review.
Oh,
right.
Okay.
So that is my guess because I still have the same question. So we merge the and song, right? So that is my question is also like this is look like grammar.
But still, I think their paper is not that well written. Those five questions, are actually summarized by me, not by their paper.
Okay.
So the first question is how stable and accurate is the estimate Sharpie value? Here, they calculate the ground truth of Sharpie value by iterate all the possible subsets. And then they report the difference between the ground truth and their estimate value. X-axis is the number of sampling times, and Y is the difference. You can see it like that. And here they found out after you sampled for 1,000 times, the result is stable.
But we still need 1,000 times. And it's also based on the size of the set, right?
The size. So to make it computable, here I think they only use sentence with less than 10 words to calculate the ground truth Sharpie value.
Yeah, I think it will make a very good contribution. We can already make a very good contribution if we can really estimate the Sharpie value, give it a base set of maybe 50K, right? Because the theoretical Sharpie value is almost incomputable.
So it's an NP hard, I guess.
Yeah.
Yeah. So anyway, from this experiment, they claim that after sampling 1,000 times, then the result is stable. So they just use 1,000 or 2,000. I'm not sure. For complex, for much more complex model, probably they use 2,000.
Yeah, and also I think the value will get exponential once the length of sentence increase. Right? Suppose it be 100, then it becomes over 100, so the sample size will get larger. So okay, so I think the triple AI is also not that hard. Okay, but anyway, we did not make it clear because we don't know the final results.
And then the second question is the assumption correct or not? So what they do is at each layer, the max density value is given by, let's say, RAB, and then they also calculate the non-adjacent node density RAC and find the next max value and compare RAB and RAC prime. So if RAB is much larger than RAC, then they think the assumption is correct.
Okay.
And yeah, so the results show that non-adjacent node interaction is insignificant. And then
I think it's case by case. So that is case by case. For example, we have some grammar. So I don't know. So if and then, right? Suppose we have such a relation. Then if and then will suppose to be two words very far away, right? But from the structure, they're supposed to be something we need to care.
Yeah, that's
right. Or we have something like otherwise, but etc. So we have for these walls. Of course, we calculate the average definitely. So walls, adjacent walls will have more interaction than non-adjacent walls. But for some walls, they may be very, very important, and there are some interaction of some special non-adjacent tokens or walls are supposed to be very, very important. But if we look into the average, we miss their importance. So that is one of my counter arguments for this question.
So this is related to the task you are working on, I guess. Or I'm not sure.
We are talking about NLP, right? So for NLP, those words are supposed to be non-negligible. I don't know, but anyway, so they can squeeze them. This is I think the contribution of this paper is that they propose a measurement for
interaction between
right.
words embedding.
Yes, and so you can see when people work on the explanation, especially for a very special paradigms of deep learning, inference is very important. And the inference not only for individual component of inference, it also looking to the inference of the interaction of the components. I think their contribution more like the invention or the proposal of the new measurement of the inference interaction or interaction of the inference of interaction. So this is basically about their contribution, and on how to calculate this inference of interaction in a precise way or in a more efficient way. It can lead the follow researcher to address that problem. And they actually the first one to propose this one and validate this one. I think that's why the paper get accepted.
Yeah. Okay, and the third question is the extracted interaction correct or not? The difficulty for evaluating this question is that it's very difficult to get the ground truth, because even sometimes if you wanted to use human interpretation as a label, it's still we have a large gap between human interpretation to it's very subjective. So what they do is first, the first experiment is to quantitatively evaluate the validity of the extracted.
So all the experiments very expensive. So I'm trying to enumerate all the possibilities and get.
So how did they do this? Is that they find some non-leaf nodes with high interaction between them, and then next step they randomly permutate that area. Not that area. They put the words in that area to other part. So anyway, they just permutate that area to make sure its interaction score lower, and then they calculate the prediction of permutated input. And if the cohesion score decrease, then that means they do find that area do have high interaction. I'm not sure I made myself clear or not.
I think that I got a big picture. So it's more like testing, right? So we calculated the interaction, the interaction score. So in this case, we want to evaluate what if they do not interact, right? So somehow we keep one token here and remove the other, right? So in this case, we can somehow experimentally evaluate the score.
But still, I'm not sure whether this answered because they try to find an objective measurement, but this didn't evaluate that.
Yeah, I think it's very hard to answer. Even if they have this value, it's still a kind of estimation.
But
But
anyway,
I think we can skip this. This is an interesting experiment, but it does
Mm.
not worth to put an effort to discuss this.
but from my
mm.
point of view, they didn't improve much than the baseline.
Is this a bit okay? So you think this is a, and then how expensive is the baseline?
I'm not sure about this.
Yeah, so I think we do not need to focus too much effort time to discuss this. So I would prefer to talk about the application and
Okay.
how this work can be can inspire us or can help us with our own research.
And the second experiment is they construct a structure like this so that they know the interaction between, let's say in this case, A1, A2, A3 should be clustered together, and A10, A11 should be clustered together. So they just basically they construct this data set where we know the ground truth before, and then see the results. And the result is that their method is the best.
Okay.
And then the fourth question is, how can this method be used to explain a model? They compare of tree generated by different deep neural network on different data set. The first example is this bird trained on SST2 data set. I think this data set is to evaluate binary sentiment. I'm not sure if I is that correct. From my memory, it wants to predict whether this sentence is positive or negative.
You got a point. You can keep going.
And they found that, yeah, they highlight the first merge, second merge, and third merge from the sentence. And they found that those merge all are all constituent with distinct emotional attitudes that have strong interactions and that have strong interactions.
This is very subjective. Right, how and up and to, or maybe up to is
not sure, but that's
yeah,
the result.
Maybe they make a point here.
And the second example is different DNN learned on COLA dataset. I think this dataset want to predict whether this sentence is problematic or not in terms of syntax. And so they do something like this. They show the first merge, second merge, and third merge. And then they found that different DNN have different patterns.
Okay. That's surprising.
And
okay,
then, yeah. And then the third example is they show this example to show how model give the correct prediction. So in the first step, they merge widely. That means
okay,
so some the color represents positive or negative, and in the from step 2 to step 3, the emotional was in the step 2, the emotional was towards a positive attitude. However, because the interaction between emotional and inconsistent, then this emotional becomes negative. So you kind of see how it becomes, how this sentence be predicted as negative.
So the key steps are step 3, right? So the point is that after interaction between inconsistent and emotional, and the sentence will turn into the positive.
It turn into negative.
Turn. Yeah, the word emotional becomes negative.
That's the point of this example.
Okay.
So that's all. That's
Okay.
all about their case studies.
Yeah. Okay. So let's keep going.
And the fifth question is, how different are the tree generated by this method and syntactic tree? They calculate the fitness score between their tree and syntactic trees and found out there's no correlation between them. I guess I didn't look up what the meaning of unlabeled F1 score. I'm not sure, but the point is that the score is different for those two trees, so they are different.
Okay. Basically, it's so they want to ask that if we're using the grammar or syntax to get such a tree, and whether it is replaceable or still achieve a high value. But the reading is not no. Okay.
Yeah. So that's all.
Yeah, I think Xianglin make a very good presentation, and in terms of this paper, to me it's more like a tool. It's more like a tool, and I think of course the concepts of inference is very important. Sharpie value is important, and also the Sharpie value for interaction is also very important. But how to calculate? But for us, we are not looking to an individual sample. I think for Professor Chen Zhang's work, they are more looking to the attribution problem. The attribution problem is more focused on the individual sample instead of a group of samples, right? And for our work, we're looking to a group of sample, the whole data set, and how this data set, maybe the noise data, maybe the active learning, the sample selected through active learning algorithms will have a good inference, and whether they can be interacted. So that is also very, very, very important and interesting questions. But my concern is that if we want to use this idea, adopt this idea into our own work, the computational expense is a large problem. How do we calculate that effectively? And also, how do we sample a
I
reasonable?
think there are some papers specifically working on that problem.
Yeah.
So how to sample Sharpie value in order to make it more close to the ground truth.
Okay. If we need it, we can look into more details. But anyway, it's very good to know that some researchers, especially, and it's good to know that the evaluation and the measurement of the inference of the interaction is just proposed in this year. So there are still, in this book, is still be considered as a novel and kind of a state of the art. Okay,
Yeah,
is
so
there
that's
any other
when-
question? Yeah, is there any questions for Xianglin on this paper? Okay, if there's no question for Xianglin, now let's turn to something more practical. Yuchen and Darien. I don't know how you interact and this, and as long maybe you can see the Sharpie value of the cooperation between Yuchen and Darien. So Yuchen, that's just a joke, right? Yuchen, will you please share the screens and let us to follow the practice of Github Action. I'm not sure who will be the first, Darien or you.
Give me a while.
Okay.
I need to set it up on my computer again.
Okay.
I guess for the flow of this tutorial, we'll just briefly go through the slides again, and then Darien will just take over and do the demo for Java, and then afterwards I'll do the demo for CML.
Okay.
Yeah, so okay. Okay, yeah. So I guess I'll start now. So the idea of GitHub Actions, we'll just go through again. It's quite simple. It's basically to automate some tasks with your software development lifecycle. And how it works is that you're supposed to specify some triggers or specific events that happens on GitHub, and then that will basically trigger your workflow to run. So the GitHub Actions is made up of workflows. The workflows can contain several jobs. And then in each job, there are several steps which perform certain actions.
Sorry. How many actions can one step perform?
How many actions can one step perform? It should be a one-to-one mapping. So each step is one action.
Each step is one action. So if it's one-to-one mapping, why we need these two concepts, step and action?
Yeah, so sometimes the action itself can be made up of like multiple commands, and sometimes it's also like for scoping and just like generally good documentation, because for your steps you can label it with the name, and then like you can also specify certain environment variables that are only accessible in one step.
Okay.
So yeah, so it's like just
basically a unit and provides some skeleton.
Yep.
Okay.
The runners are basically the servers that run your GitHub Actions. In this case, this is done by GitHub, so we don't really have to worry about it. This slide here is just to let you know that you can host your own runners if you want to. And then here we have the syntax of a workflow. So for GitHub Actions, we use the YAML syntax to define our workflows. All the workflow files must be stored in .github/workflows. And this is just the convention for getting it to work. The YAML syntax is indentation based, and you can basically think of it like a JSON object. So we have a very simple example of a workflow file here. In this case, some of these attributes are compulsory, like the name. So this is the name of our entire workflow. And then on specifies like the list of events that we want to trigger on. In this case, it would be push, or it can be pull request as well. And then in jobs, we basically list the different jobs that we want. So check batch version here is the name of the job. And then attributes for this job are like the OS that it runs on, and then the steps that is comprised of the job. Yep. I guess it's best if we go straight into the example. And yep, so Darien has prepared a repo over here for you to follow through. I'll let Darien.
Maybe you can share the URLs and we can follow.
Yeah.
Do we need to fork it, or will everyone share this address?
Yeah, so about that, what I plan to do is I plan to do a quick walkthrough where you can make a PR, show that some tests are failing from the workflow. So you have implement a workflow and show that some tests are failing, and then fix the test. So just like a run through of how the process in a repo would go for using workflow to trigger your CI/CD. So yeah, it'd be best if you can fork it, I suppose.
Okay.
Yeah,
So
I guess I'll stop share now, and Darien, you can take it away.
Okay. All right. So this is the repo. So we can see. Let's take a look what's in the repo real quick. So we'll see two branches. So the idea behind this is that I've just got the repo components here. So the idea behind this is that if we look at the repo, we have a branch. We have some functionality in the master branch. So you can see one prime. This is the current branch. Let me change the branch.
So should we practice now, or we wait for your explanation and practice ourselves later?
Well, if you want to
maybe-
practice later, it's fine. So I'll just do a quick walkthrough so that everyone's on the same page as well.
Sure.
Yeah. So now you can see we're in the master branch. So what's on the master branch here? So we see we have this say this prime checker. So suppose this is just an example of some functionality that you want to implement. So in this case, you see it's to do for now, and you have some tests. So what you want is basically we just want to write some functionality that satisfies these tests. So what the workflow will do is that the workflow will just be a guard for you to, before you merge anything to master, the workflow will make sure that you run the tests first and that your test pass before you can merge it into the master branch. Otherwise, you can set it to stop you from merging. Of course, you can also have a manual override where some people with particular permissions can choose to override the lock and just merge things to the master they want to. Yeah, it's just GitHub functionality. So here we see some tests. So as the prime checker name would suggest, the prime checker just supposed to just have one method when check on something integer is prime or not. So this is some tests that we write beforehand. So the idea being that these tests will essentially show the correctness of the functionality or not. So standard primes, large numbers, and some edge cases. So now suppose we've gotten some functionality running on a different branch. So in case we've got a separate branch where we want to implement this functionality. And what is this? This is like just to say we have some code here already. And so we want to check, does this actually satisfy the requirements? So the two ways you can do it. The first is that we can run it. Sorry, a second. The first way is that we can, for example, run the tests on our own machine, or we can open a PR and then we can run the tests directly on using the GitHub Actions workflow, and from there we will see whether or not we are ready to run it, ready to merge into master or not. So here I just give an example. So for example, if I just run the test, so this will be done using, for example, Maven test. So we see some tests are failing. So in this case, we see some tests, for example, in this particular edge case, one of the edge cases are not passing. So we can replicate this in the workflow, for example. So maybe you don't want to run this all the time on your own machine. You want to use the runner. So what you do is that you implement a workflow. So how this will be done is that we can, for example, we can look at actions and set up a workflow ourselves. So there are some pre-prepared workflows that GitHub passes you as well. For example, one for using Gradle instead of Maven. There's different ones for deploying the different services and whatnot. You can explore this in your own time, but for now, we just set up a workflow ourselves. So I've already prepared a workflow beforehand. I'm just going to show you real quick. And I'll just go through exactly what the workflow is. So we look at it again. So this thing is just a run test. So here we look at the conditions. So when will the workflow run? So here we see when you push to master or when you make a PR to master, it will run. Then this one is just for you to allow you to run it manually. So what this means that you can choose to manually trigger the workflow yourself without having to make a PR or push to master. So what does this workflow do? So this consists of building the test and building the project and then running it. So in this case, we see certain actions being used here. So these actions you can find them yourself. Somebody feature actions, you can search the marketplace for actions to use. In this case, you can check out and set up Java actions where you can specify the Java version you want to use to set up as well. You can even specify the distribution you want to use, for example. If certain distributions support different parts of Java, some distributions support Java FX, which is used in Evo Suite, and others don't. So for example, you want to specify the distribution as well. And finally, you just run the test. So in this case, just Maven clean test, very simple. So we'll just commit this to master. And now we have a workflow. So now how it triggers workflow. So I mentioned before, the workflow triggers when you make a pull request to master. So we can switch to our branch now, and check our branch, and make a pull request. Yeah, so we just create a pull request. Okay, so to trigger the action. Okay, it's still running the action currently. So if we look at the pull request, we see this yellow dot means that the workflow is being queued, so it's still running. And so we see it's failed. So you can still merge the request by overriding it, but this will prevent you from merging failing non-compliant branches into your master branch. So we look at you can even see the details of the build, for example. So what exactly Okay.
Maybe
Sorry,
it's
give me a
not
second
a,
about.
okay.
That's a separate issue. Yeah. Sorry about that.
It's okay.
If not fix it, but the general idea is that this will run the test for you, and then you can see the output of the run as well and see what happened, what changed here.
Yeah, I suggest that you leave maybe 5 to 10 minutes for students to follow this practice.
Yeah.
And
Okay.
so maybe the question here is that this it focus on nearby with the student, and I'm going to submit a pull request or full commute poetry. What did you suggest?
Sorry, can you repeat that?
So if I'm going to practice with these examples, do you suggest that I just submit the pull request to your repository, or I fork your repository on my own account?
Oh no, I would suggest so if you want to practice on your own, I'll suggest you fork the repository first. So this repository, then you on your own repository, you create a workflow first, and then you make a pull request yourself so you can understand the workflow. Yeah.
So yeah, I suggest by Darien, maybe we can try to fork the repositories and play with
Yeah. Give me a second.
Maybe it is a typo there.
Yeah, maybe. This ran the last time, so I'm not sure what exactly is not working here.
Excuse me, may I ask, it is specific for Java?
No, it's not. It's supposed to apply on Python as well. So later, Yuchen will showing a demo for deep learning application.
Yeah. I mean, doesn't really matter. Give me a second. Then pull the workflow from the previous from this one here instead, which is a distribution. Yeah, so this example of distribution you can specify as well. So this you need to specify the Java package and distribution type if you want to.
Is that problem of version? I don't know.
No, it's some distribution parameters in file, I think. So now we can rerun the thing again, see how it looks. I expect it to fail because some tests don't pass, but I expect to build properly. So that's the main part that we're looking at. Yeah, okay, it builds. Great.
Works now, right?
Yeah, it builds fine. So
probably supposed to be failure test case.
Yeah, so what we can do is that we can trigger a new build here. And this should work. Yep, so now it's being triggered again. Yeah, so you can even check the progress yourself if you want to.
Yeah, maybe we can select the correct version. So, so in this case, I suggest all the audience, if possible, you can try to fork their ranks repository and try to create a YAML file and run it on your own on laptop or desktop.
Sorry, but yeah, that's the general idea of it. So
yeah, so maybe I leave this to 5 to 10 minutes, and let all the students and audience to have a try to practice this. And,
yeah.
No, there is still sharing. Okay.
Oh, then env dot. If you're not able to see, I can expand it a little bit. Yep, so in this case, this is how you access the environment variable outside of the step scope. Now, within the steps, you can also specify more environment variables. So the environment variables are key value pairs. The keys themselves are case sensitive. And let's say that in the command line application, you're trying to access it, it will just follow basically the shell language. So in this case, we have just $sign first name to access the environment variable first name. Yeah, okay, so there are some defaults, default environment variables that GitHub Actions provides. And these will be inside this link here. I think I will just send this into the chat. And then if you want to look at it, you can do so. I guess for our next demo, this is not very important. Okay, so next up is the secrets. So secrets, once again, we access it from the secrets context. So we can see from this syntax here, if we want to access some secret, it's the same $ bracket bracket, and then secrets dot, and then whatever secret it is. So in the case of with is basically the same as environment, except they do some name wrangling. So in the end, your secret is still an environment variable on the runner, but it has a different key. Yeah, it has a different key as opposed to just like super secret in this case. So once again, it's not super important, but just in case you see something, see some similar syntax like that, you realize that, okay, so it's actually not accessible in the repo itself. Right, and just to show you this, if you want to specify your own secrets, they'll be under the settings file. And from the settings tab, we go up down here to secrets. And you can create your new repository secrets over here. Yep. All right, so in the case of ML ops, we don't exactly have test cases to run against. And what I see on the internet is that people basically use GitHub Actions to create a report on your pull request. And how they do that is with this tool called CML. CML basically packages the output of your machine learning workflow, and then the key actions to take note of is just CML publish, which holds an image to be put inside your markdown report. And then the CML send command, which basically sends the markdown report as a comment in your workflow. Usually it works with DVC, and DVC is basically like Maven or Makefile, but for machine learning. And it fulfills the roles of like version control for the data and models. And in this case, since DVC is actually a very deep topic, I decided not to go very in depth into this topic today. So once again, if you're interested, you can go read up on DVC. So actually CML and DVC are by the same organization called iterative.ai. Yeah. All right, so for this demo, I guess what we'll do is, I think I'll let you guys try to fork first. So let me send this link into the chat. Okay, so I guess what everybody can do now is to just fork and then clone this repo locally. And what I'll do is to bring you guys through how to set up the CML to publish a report. I think, yeah, you can try to do it yourself first. So maybe after 1 or 2 minutes, I'll bring everyone through the next step. And then if you manage to complete it already, you can just go ahead and you can try some bonus tasks if you're interested. Yep, so I guess for now, everybody can try to clone this repo first and then try to train the model and see what happens.
Please feel to raise any questions when you have any problems when installing, even installing pip install or train a Python.
This is for Python 3.
Yep. Okay, so in this case, I'm using Python 3.8. If you have basically pulled the repo already, what you can do is try to just run the train.py file. And then what we'll see here is that this training file generates 2 output files, right? So it writes the accuracy into matrix.txt, and then it also plots a confusion matrix and saves it as confusion matrix.png. So if you are able to see this, then you can try to move on to the next step and try to create a workflow file for this repo. Right, so if you do not have a guide on how to start, you can look at the latest link that I sent. So over here is the getting started guide for CML itself. And if you just go down here, you can just, you can see right here that they ask you to copy this. So you can use this as a base for the task. Yep.
Hi, Yuchen, supposed to be a small mistake. I just remembered it's the requirements for TXT, right?
Oh, yes.
This is your last slide.
Yep. Yep. Okay, so
if you got a CML, then you can publish your result automatically. Do you mean this is the CML?
Yep. Yep. This will basically create a small report every time you make a pull request. So we'll see what that looks like. Okay, let's create the workflow file and then okay, so right now here we have an empty CML file, right? And then we'll just follow the instructions and make a copy. All right, so the name of our workflow is called model training, and then it runs on push. In this case, I'm not very interested in all the push, so I'll just use a pull request. Now, if we go down here, okay, we see that it uses setup Python. The setup Python that they are going to, the Python version that basically this action is going to provide is going to be 3.10. So actually we don't really want that because there is some issues with, I think it's scikit-learn and 3.10. So let's say that we want to downgrade the version, right? So what do? Let's search up the Python actions, setup Python. And then we see what the documentation says. right? So if we want to specify the version, we can use something like this. So what I'll do is I'll follow the guide and put a width. And my Python version will be 3.9. Yep, I think 3.9 should work. Okay, so as you can see, we need to supply the GitHub token secret in order for CML to be able to have the authorization to send a comment. And so what this is doing, we are just installing the dependencies. We're running the train. So this file will generate our metrics.txt and the confusion matrix, right? So all we're doing is basically appending the contents of the metric txt and the confusion matrix into a new file called report.markdown. And then we are asking CML to just send this as a comment to our pull request. Okay, so since we are on master branch, let's create a new branch. And we'll commit the files here. Yeah, is everyone able to reach the same step as me?
Can you copy and paste? You have sent the, oh, you do send the, can you copy and paste the scripts in the chat?
Yeah, sure.
Maybe you can also send the file in the WeChat link. That is also fine.
Okay, so if you're following, you would have this other branch in your repository. So since our workflow only triggers on pull requests, we should open a pull request. Make sure that when you open the pull request, since this is a forked repository, make sure that you are making a pull request to your own repository. Yep, so if we create the pull request now, this should basically start the workflow. Oh, seems like I didn't commit.
By the way, Yuchen, does the YAML file's name matters?
It does not, but it has to be in the correct folder.
Okay, suppose I have two YAML files. What will happen? They will run all of them.
Yep. So it will just run all the jobs in all the files in parallel. Okay, so with any luck, your workflow should be able to complete successfully. And then what we'll see here is a report generated by our own files, actually. So we can see this is the contents of your metrics.txt, and then this is basically your confusion matrix. So as an experiment, you can try changing the classifier, or you can change the depth and then make another push and see what kind of changes happen.
Okay, anyone is still following, you can just stop Yuchen and ask him to go back if you didn't follow it. So maybe I can just make it more flexible.
Yeah, sorry, may I ask? Actually, I saw that it's running in the actions, but actually I didn't find it from the pull request. Is there any problem?
What do you mean by
Maybe Dr.
finding
Shaya,
in
you
the
can
pull
share
request?
your screen so Yuchen can see it.
Okay.
So do we need to set on the actions?
From the UI, is it? It's not necessary. Yeah. So we are looking at the same job, so it's fine. Yeah.
Yeah, but I didn't find anything here. I directly click here and find it's running.
I see. Can you open the workflow file?
Workflow.
So maybe it's the pull instead of push instead of pull request.
Yeah.
Let's see.
Yeah.
Yes,
so
push,
in this
yes,
case,
push,
it's on
yeah.
push.
So there's no pull request.
Oh. Okay, I see.
But if you create a pull request, you should still be able to see the same thing.
Yeah, so I think so that is okay.
Okay, thank you.
I think for your Python version, there's a typo, so it might be stuck there. So yeah.
Yeah, Yifan, do you have any question so that I can share the screen? Hello, Yifan.
Hello. Maybe I can share my screen, but maybe I made something wrong, so I can't get the result because I use the PyCharm, and he set all the file, all the py file in the VNV folder.
Oh, you created. So no need to import it.
So
anyway,
no need to use the PyCharm. I don't know.
No need. There's
Yeah, so I can't get the result. I found that. So this line should be changed to pull request. Then you can see on the pull request. Is it true?
I think push can also be fine.
Yeah, push is also fine. So for your pull request, you should put the underscore instead of space. That's one. And then for the directory, right, you should move it outside of the virtual environment.
Okay.
Because I think the virtual environment is ignored, right? So it won't be seen by GitHub, then it can't run.
Okay, let me try.
Yuchen, by the way, I find that the README is not updated.
For which thing?
For when I push it and when I after I run the Python train.py, and didn't. Maybe I can share my screen.
Yeah.
So this is what we have. So after the checkout at V2, it is just finished. And I told you that no complete.
Okay. So
that is basically what we have, right? But I supposed to change it to. I supposed to change it to update my report. Oh, sorry, it's the report one. So supposed to be.
yeah, the report.md is like a temporary file that only exists on the runner.
All right. I see. I got it. So is that possible to update the README files?
Yeah, it's possible, but I think I don't know how to do it right now. You will have to look into the documentation for actions. Yeah.
I see. Okay. Thanks, Yuchen. Does anyone have questions, or if I still want to stay here for